In that way, the math game can continue and you can invent dark matter and black holes or any other unobservable fairy at the bottom of the garden to keep the fictional story alive. And this is what's happened. So we don't understand gravity. Newton described it with his equation, force equals the gravitational constant, big G. Multiply that with the masses of two objects. The question is not answered. How does this mass know about that mass? How can this be so? And the equation says you divide by the distance between them squared. And it works. I mean, NASA uses this equation to navigate the solar system. You'll note that it's the same form as the electric force. You just substitute there for the masses, the two charges. But as we saw yesterday with Jerry Pollack's talk, that force is enormous compared with the gravitational force. So this suggests that mass may be understood electrically. If you can substitute charge for mass and you come up with an electrical force, then perhaps mass can be understood electrically. So to understand gravity, we must understand why matter has mass. And as I pointed out with the Higgs boson, they've got no idea. You'll notice that Newton's equation does not refer to time. It's instantaneous. And this is glossed over. In the electric universe, however, this instantaneous connection is absolutely essential for coherence. For coherence of atoms, so that they're stable particles, for coherence of planetary systems, so that the Earth knows where the sun is right now, and in galaxies, so that you can form a spiral. The stars on one side have no idea where the other stars are until 100,000 years later. How do you form a beautiful spiral? And even at the subatomic level. Now this universal gravitational constant, big G, has the peculiar dimensions, and this is a mathematical term, it has nothing to do with the three dimensions of space, of length, mass, and time. But time has no length or direction in space. This is where you get this confusion when the word dimension is used. And you get into all sorts of mystical talk. In fact, I would suggest that it was science that started the kind of New Age ideas where people talk about extra dimensions and so on. In the electric universe, there's no need for that. The universe can be as wonderful and mysterious as we observe in the three physical dimensions we have, but that goes much deeper. So G actually should not be a constant because it refers to mass. And as I said before, mass is the energy tied up in a particle. It's an electrical variable. So G is not universal. That means that big G, which we measure on Earth, is neither universal nor a constant. And in fact, it's the worst defined constant in physics. Every time it's measured, it's different. And even using the same equipment, it varies. So what I would suggest is there is more complexity in the effects attributed to gravity. I say attributed because in some cases we're looking at actual electromagnetic forces, and I'll talk about that, and it's mistaken for gravity. It has more complexity than any equation yet devised can explain. It depends on the context whether it's actually valid or not. It's not universal. We repeated the mistake of Earth-centrism. In other words, we measure G on Earth and then apply it throughout the universe. What gave us the right to do that? So we have selective blindness towards conflicting evidence, and we invent dark matter and dark energy, all this stuff. And for example, these pictures that I've got here, and as Anna's said in her talk, we ignore the fossil record of impossibly huge creatures. The ultrasaur in today's terms, would have weighed 180 tons. And the maximum force exerted by any muscle is independent of body size and is the same for the mouse as the elephant. In the antediluvian world, 350-pound flying creatures soared in skies which no longer permit flying creatures above 30 pounds or so. And the ultrasaw's neck in today's gravity would have caused a 430,000 foot-pound torque where it attached to the body. Even a steel girder of the same mass as that neck would have sagged under that weight. Also, we know observationally that spacecraft show anomalies in Earth flybys, and comets exhibit what's called non-gravitational forces. That's what makes them difficult to predict their returns. And people who have measured gravity, or the change in gravity as you go down deep mine shafts and so on, actually said it looks like there's a fifth force. It's not changing the way we expect from Newton's law. And people who have measured gravity going up towers have said maybe there's a sixth force because that doesn't conform to Newton's law either. It was pointed out to me a few months ago that if you calculate using Newton's law the force of the sun on the moon and the force of the earth on the moon, when the moon is between the earth and the sun at new moon, the sun is pulling on the moon twice as strongly as the earth. And the question is, well, how do we have the moon? That's a good question. None of these questions are answered by Newton's simple equation. Of course, if big G is universal, if we use G measured on Earth's surface, the comet 67P looks like solid rock, while its density appears to be that of highly porous dust and ice. And I have repeatedly in the Space News on the Thunderbolts website pointed this out. The planet Saturn appears to have a lower density than water. It could float in water according to using big G as we measure it on Earth. And the composition of the sun is calculated to be mostly hydrogen, right down to the very core. Now, what body the size of the sun would have hydrogen gas in its core? If you were to look at the Earth and if its ionosphere was lit brightly, rather like the sun, and you saw oxygen and nitrogen and so on in the atmosphere, would you say that the core of the Earth was then oxygen and nitrogen? No, you'd say more likely to have heavy elements. You saw oxygen and nitrogen and so on in the atmosphere, would you say that the core... And this is where we get to the principles of classical physics, and that is that good physics needs to be simple. If I can't explain to you in physical terms what I'm talking about, and simply, then you have every right to go and ask somebody else. Michael Faraday, the great experimentalist, could see the possibility of an electrical nature of the force of gravity. Remember I said the two equations are the same form. And he wrote, "The long and constant persuasion that all the forces of nature are mutually dependent, having one common origin," that's the electric universe position, "or rather being different manifestations of one fundamental power," once again the electric universe idea, "has often made me think on the possibility of establishing by experiment a connection between gravity and electricity." And he went on to say, "No terms could exaggerate the value of the relation they would establish precisely." Now, if people had followed Faraday's intuition, we would be several centuries advanced, I would say, in our science. But of course, this poses the key question. The electric force is both attractive between opposite charges and repulsive between similar charges. But gravity seems to only attract. Why is that so? And here's a character who was around at the time of Einstein. Sir Oliver Lodge was a British physicist and writer, best known for his contributions to the development of wireless telegraphy. He perfected a radio wave detector and the heart of the early radio telegraph receiver. He was the first person to transmit a radio signal 1 year before Marconi did, and received international recognition for his work. Lodge is also remembered for his work on the ether, which had been proposed as the wave-bearing medium filling space, and of course, which the electric universe relies upon. Other scientific work included investigations on lightning, the source of the electromotive force in the voltaic cell or battery, electrolysis, the application of electricity to the dispersal of fog and smoke. He also invented electric spark ignition for the internal combustion engine. He was a practical man. Rather like your Faraday, he was prepared to experiment and try things. He was critical of the new theories of relativity proposed by Einstein. I would suggest that if education was done properly, his arguments against Einstein would be placed against Einstein's arguments, and students allowed to judge for themselves. Referring to Isaac Newton, he wrote, "What is really wanted for a truly natural philosophy is a supplement to Newtonian mechanics, expressed in terms of the medium which he suspected and sought after but could not attain, and introducing the additional facts, chiefly electrical, especially the fact of variable inertia discovered since his time." That was in Nature, Feb 17, 1921. Lodge seemed to be fully aware that Newton's mechanics needed to take into account electrical effects on the masses involved. This is a pivotal idea for gravity. Understanding gravity is essential to be able to express mass in terms of weight in kilograms. So here was a guy, another one, who was well on the way. Once again, good physics needs to be simple. Sir Oliver wrote, "It may be that when the structure of an electron," remember at present it has no structure, "once it's understood, we shall see that an even-powered stress in the surrounding ether is necessarily involved. What I do feel instinctively is that this is the direction for discovery, and what is needed is something internal and intrinsic, and that all attempts to explain gravitation as due to the action of some external agency, whether flying particles or impinging waves or Higgs bosons," he could have said, "are doomed to failure." He's probably spinning in his grave at the waste of the LHC experiment. He showed insight and uncommon sense with his idea that the electron must have structure. All subatomic particles must have a charged subparticle structure and orbital motion to have self-energy or mass, and exhibit magnetic polarization, which is called confusingly spin by particle physicists. It's where language gets into the way of physics today as well. Now, if we're going to talk about particles and matter, we have to look at the scale of the atom to give you some idea of what we're talking about. The first step, then, is to give some idea of scale. As I said before, modern particle theory is no help because specialists were still arguing over what is really real in Nature last month. This picture gives an idea that the classical atom is mostly empty space, with the charged particles invisible on this scale. It's easy to see how an electron orbiting the nucleus can only shield the nuclear charge from a nearby atom for a fraction of the time it takes in its orbit. Because at some points, or most of the points in the orbit, the proton, for instance, the charge on the proton is visible to a nearby atom, and the same thing for the other atom. So it gives you the idea that if those two atoms can synchronize their orbits, they can then come together and form a molecule. So, as it says there, if the nucleus was the size of a ping pong ball, the electrons would be the size of a flea orbiting outside this stadium, which is in Melbourne Cricket Ground in Australia, one of our famous institutions. Here's another guy. You don't hear about these people. I think Newton said that if he'd seen far, it was because he'd stood on the shoulders of giants. I would suggest that you have to be very careful in your choice of giant because he may be facing the wrong way. These are the people who should be in our science education curricula. Fritz London was a philosopher of science, a visionary logician and dedicated theoretician. In 1930, Fritz London explained the weak attractive dipole electric bonding force between atoms. known as the van der Waals dispersion force, or it was named after him also as the London force, which causes gas molecules to condense and form liquids and solids. In other words, planets and you and I and everything in the visible universe. The London force originates in oscillating electric dipoles caused by slight distortion of otherwise electrically neutral atoms. So here we're talking about the kind of stuff that the Earth and the planets and the Sun that are made up of. The tiny electric dipoles arise because the charges within the atom are separated, as shown in the last slide, by effectively a huge distance. The electric dipoles resonate, as I said, they sort of tune into each other and orbit in such a way that they combine. It's always attractive, just like gravity. So there's a clue. So, in fact, Fritz London said that it seems that gravity may be this kind of interaction between neutral matter. So it seems that the clue about the real nature of gravity has been available to chemists who are not interested in gravity and unavailable to astrophysicists who are not concerned with physical chemistry or electricity. Obviously, gravity has the distinction of being much, much weaker than the force between atoms, the London force. But that should be a clue. We are bonded to the Earth by a similar but far weaker version of the London force between atoms. And here we get into the idea of repeated patterns in the electric universe. So like gravity, the London force is always attractive and operates between electrically neutral atoms and molecules. Very much like gravity. So we talk about matter and mass. So the second step on the path to discovery about what gravity really is to look at the particles that make up matter. Newton's law multiplies the masses of two objects together, so the first requirement is to define what is meant by mass. The electron is defined as a fundamental indivisible particle, but it must be a composite of smaller orbiting charged particles, shown here in blue, to store energy. The energy is stored by the motion of those charged particles with respect to one another and also with respect to all other particles in the universe. The same goes for all subatomic particles. It doesn't matter what it is, including the neutrino. The neutrino also is included. And there was a report that I got yesterday that they have now shown that the neutrino has mass. Now, the very idea that it didn't have mass meant that it couldn't have been a real particle anyway, because there was no such thing as a particle with no mass. The problem then was that, according to the standard particle, or standard model of subatomic particles, the neutrino doesn't interact with the Higgs field, as it's called. That meant that there was something seriously wrong with the standard model. So what has happened? They've said, this gives us opportunity to modify the standard model. In other words, please send more money. The electron is defined, as I said, as a fundamental indivisible particle. And it goes for all subatomic particles. And this simple repeated atomic model is at a far smaller scale. You remember the ping pong ball in the middle of that ground and the flea on the outside? That means within those tiny objects, there's also spinning charged smaller objects. Who is to say where we stand in the cosmic scale of things? Now, Ralph Sainsbury, who was the fellow I mentioned earlier, who published this idea of electron structure, showed that you could actually derive the magnetic force from this structure. In other words, it's a version of the electric force, and gravity from this structure is another weak form of the electric force. So here we are, we're doing what classical physics was designed to do, simplify. Now they hand out Nobel Prizes for inventing more forces and more particles, and we know less and less the more they do that. Ralph Sainsbury, though, said if you calculate the speed of these orbiting little subparticles inside the electron, it's phenomenally faster than the speed of light. He calculated that if those tiny little subparticles were to be released from the electron, they could travel from here to the far side of the Andromeda galaxy in 1 second. This comes back to Newton's law, which doesn't involve time. In other words, it says it's instantaneous. Well, that kind of speed is instantaneous on our scale and on a galactic scale. Tom Van Flandern did his own astronomical calculations to point out that the Earth orbits the Sun, and it knows where the Sun is right now. It's fairly easy to determine that. And by using a more stringent test, he calculated that the speed of gravity exceeded 20 billion times the speed of light. So the difference between that and Ralph Sainsbury's was about of the order of 1,000 times. Ralph Sainsbury's is probably more accurate. The electric force between matter particles must operate instantly on our scale of things for the electron to be stable. Something that comes out of this is that once you have the speed of information exchange almost infinite, then time is universal. Time has nothing to do with Einstein's clocks. Clocks are physical things. They're made up of atoms and so on, and their environment can change the way they tick. So to use the clock as a surrogate for the concept of time is completely inadmissible. So Einstein's special theory of relativity, I'm afraid, is discounted immediately. So, Newton was right. Gravity is effectively instantaneous. And Einstein strayed from the path to discovery by postulating the speed of light as the maximum speed for information transfer. When he did that, he disconnected everything. He made an unworkable universe. To have a workable universe, all of the components of the universe must know what all the other components are doing in real time. The difference between this idea and Einstein's is rather like drop a pebble into a pond and you pick up the sound wave, which is a compressional direct wave. It's much faster than the ripple itself, which takes time. Light is a ripple. It takes time to pass through the ether, the medium, to the receiver. That's enough of that. With the real meaning for mass, we can attempt to give real meaning to energy as represented by the equation that everyone has seen but no one understands. Energy is charged matter in motion relative to the charged matter in the rest of the universe. That's the first physical definition I think you'll ever see. Because if you look up encyclopedias and textbooks, they give examples of how one changes from one form to another. They don't actually explain at a fundamental level what it is. That's the one. Electromagnetic energy is stored in the resonant orbital structure of all subatomic particles. It's matter in motion. And the mass of a particle is a measure of how much energy is absorbed internally in its deformation rather than its acceleration. It's rather like having a balloon full of water. And you poke it, it resists moving and deforms instead. Well, these particles do the same. And this is why what's his name again? The chap earlier who I mentioned, he said that we had to look at the electrical, or the idea that when you put electrical energy into a particle, like in a particle accelerator, the mass of that particle seems to change. It's that concept that you really had to focus on. So what causes gravity? The gravitational mass equals the inertial mass. That's lifting and pushing. So much the same mechanism is responsible for gravity. Now, atomic electrostatic dipoles, as I talked about with the London force and so on, are formed by most atoms inside the Earth with the inner pole positive and the outer pole negative. The reason is that gravity is pulling on the nucleus. You can't shield gravity. That's the point. So the fact that the electron's down there doesn't matter so much, except that it holds the nucleus back from moving in the gravitational field.
Come on.
The nucleus is about 1,800 times heavier than the electron. So if it moves in the direction that gravity is pulling it, then the atom is distorted, as I've shown there, which means that the bottom end of that atom is more positive than the end nearest the surface, which is more negative, simply because the electron spends more time out at the top of the curve and a short amount of time at the bottom. So, the electric field produced within the atom distorts the subatomic particles. So, the particles within the atom, the nucleus and the electron, are all distorted similarly by a very tiny amount. And this is the distinction between the gravitational force and the electric force. The amount of distortion is infinitesimal. 10 to the minus 38, 10 to the minus 39 times the gravitational force. So, it is the sum of all of the aligned subatomic dipoles that produces the profoundly weak force of gravity. And the fact that they're held by the molecular forces, which is far stronger, means that the atom can't move, the nucleus just sits there and everything's in balance, but there is this weak electric dipole force which is transferred through the body. And gravity cannot be shielded electrically because this dipole force is like a whole string of magnets. And if you have a string of magnets on a slippery surface and jostle them around, they'll all connect one to the other, a chain of them. And this is exactly a similar process here. Now, here we go. Gravity has two poles like a bar magnet. And this answers the question about why is gravity always attractive. It's because we stand on the surface of the Earth. And this is the third step on the path to discovery. Gravitationally induced atomic dipoles set up an internal gravitational field that is weakly repulsive. You've got all of the positive ends of these dipoles facing one another inside the Earth. So on stars and planets, the attractive force between atoms is strong enough to hold these tiny dipoles in place. They can't fall. And so the internal pressure inside these large bodies, like planets and so on, is relieved. There is a kind of anti-gravity effect inside, and this is probably why measurements taken down deep mine shafts don't conform to Newton's law. All stars and planets in the universe repel each other with an inverse square law force because this is like a charged particle. It may have significance for understanding charged particles themselves. It suggests even lower levels of structure. Now this is interesting. I mean, all stars and planets in the universe repel each other. Newton's attractive force has a limited sphere of influence. This may explain many anomalies. In fact, as I mentioned, the mines and towers and the fifth and sixth force, the complex structure and odd features of an inner core found inside the Earth by seismologists may have an explanation based on such a model. This is very recent. They found this odd structure to the inner core of the Earth. We're part of the Earth. It's like the molecular force at a very low level. The fact that we're attracted to the Earth is the same process, but at a different scale. We're bonded to the Earth by the dipoles induced in us, the effects like that of a magnet on an unmagnetized steel ball. We therefore assumed that gravity is always attractive. And also it's a mistake to assume that G measured on Earth is a universal constant. It depends on the polarization of the Earth itself. And that can be varied by adding or subtracting charge from the surface. The mass of a body varies with its surface charge. So when the thunderbolts of the gods were hurtling around and the planets were on orbits which meant that they came close to one another, enough to exchange charge strongly, the masses were changing. So gravity repels. This is an odd idea, but it's not new. In fact, Newton considered it as a possibility because there was a theory which seemed to work. The pushing theory of gravity was originally proposed by Newton's colleague Nicolas Flatio de Douillet in 1690 and later by Georges Louis Lesage in 1748, a long time ago. They said that an omnidirectional flux of small particles permeates space and tends to push objects together. And because they mutually shield each other, it gives the effect that looks like gravity, and mathematically it works. It was known later as the Flatio-Lesage theory and was considered seriously by many scholars, including Newton, but was discarded for very good reasons. If you have particles impacting a body, you're releasing energy, and the energy to keep the Earth in orbit around the Sun would have been enough to vaporize it. However, more recently, catch up here, Halton Arp, also known as the modern Galileo, discovered intrinsic redshift of quasars, and Anna's talked about that. And he came up with, once you get rid of this redshift equals speed of recession, which gives you the distance, once you got rid of that, he found out that the universe was fairly static. But then he had a problem. If it's static, how can that be so if gravity is an attracting force? Everything should be falling in towards one another. But he didn't observe that. So he actually, as he said here in this paper, he had an observational requirement to consider what he called Lesage gravity, pushing gravity. He said, for many years I never questioned the obvious fact that the masses attracted each other. The attraction was so blatant that it required no thought. So unfortunately, it's a situation in astronomy right now. It requires no thought. But then observations of galaxies and quasars forced me to accept the fact that extragalactic redshifts were primarily intrinsic and not the result of recessional velocity in an expanding universe. So he went on, it is interesting how the crumbling of one fundamental assumption can have reverberations throughout the whole underpinning of science. I have the greatest respect for that man. He was prepared to go wherever the observational requirements led him. Sign of a real scientist. This is the Hubble Ultra Deep Field of 2014, exposure time of 600 hours. It's merely the visible part of what's pushing in on us. Arp showed that these faint redshifted objects are not distant objects necessarily. So even though this is a deep field, it doesn't mean that they're far away. This is just looking with very long exposure at things, the redshifted objects, and they are relatively close. They're mixed up with all of the bright nearby stuff. In other words, there was no Big Bang. I mean, that Big Bang was just a religious rewrite. So, astronomy has a massive problem. With repulsive gravity, collisions tend to be avoided. But the problem is for astronomy is that with attractive gravity, all you have is attraction, collisions, and explosions. That's why a Big Bang was necessary in the beginning. You'll notice in this picture too, there are no lightning bolts. That's a grave mistake. Is there a method to stabilize the chaotic nature of a many-body gravitational system? This was alluded to also by Annis. What happens to orbits if we vary the mass of a planet electrically, remembering the dinosaurs and the sudden change? Well, as we've seen, and with the Birkeland currents and so on, we can transfer electric currents through plasma. And of course, the solar system is bathed in the solar plasma. And here the electric universe model meshes with the plasma universe and all of the peer-reviewed literature on plasma cosmology. Now, I've presented this in more detail, and it's available on YouTube, so I won't go into detail here, but the idea is to show that the radius of the orbit of a planet of mass, say M1, changes with the radius and the mass are proportional for a constant orbital energy. That means that if the mass of a planet, via, say, an electrical discharge, thunderbolt of the gods, was to double its orbit, the radius of its orbit would double, it would move out. And this is important because you can then establish order out of chaos. Now, in the case of Venus, they've already detected these stringy things, in other words, Birkeland currents, flowing between Venus and the Earth during conjunction there. In other words, that tail you see behind Venus has been detected by a spacecraft, I can't remember which one it was, many decades ago. I think this was back in the 1980s when it was reported. Now, in the electric universe, each planet is a small cathode in the solar discharge, and the electrons are actually transferred from Venus towards the Earth. It was a SOHO spacecraft, by the way. So the Birkeland currents transfer electrons from the inner planet to the outer one. The result is to increase the mass of the outer planet. Remember, the outer pole of those little gravitational dipoles is negative. If you add more charge, negative charge to that body, it increases the strength of that force. In other words, the mass of the body appears to increase, its gravitational field increases. But in this case, because of what I'd done in that earlier slide of high school physics, the outer planet will move away, get out of harm's way. Seems like a pretty good idea. So the tendency is for the orbits to change in such a way that this exchange of charge is minimized. Even now, when Mars is behind the Earth, they get what they call the blue clearing in the ionosphere of Mars, and those huge dust storms, all electrical effects. So the Earth still tickles Mars and Venus still tickles the Earth, but in prior times, during close approaches, those effects would have been far more powerful and marked. So stability is achieved rapidly, which was a requirement, of course, for mankind to survive. The important thing to recognize is that the electric universe model doesn't discard gravity. It does what Faraday wanted, to explain gravity in electrical terms. So inertial mass equivalence simply explained by this because it's all electrical. When you push an object, it's electrical repulsion, and gravity operates by electrical distortion of particles in the same way. But simply because the effect of acceleration upon an atom is to produce the same offset of the heavy nucleus within the atom as does gravity upon an atom fixed in a gravitational field. So when you're falling, actually all of the nuclei in your body move to the center of the atom. You are weightless, massless, so to speak. This little video I enjoy, because this raises the question about gyroscopes. The gyroscope spins the atoms in the periphery at many times the force of gravity. In fact, they measure I remember those centrifuges where they used to put the astronauts for training in higher gravity. All of the nuclei in the atoms of the astronaut's body will shift towards the periphery, and the same in a gyroscope. Now this guy, while he was Professor of Electrical Engineering at Imperial College in London, Professor Laithwaite was invited to give a Royal Institution lecture. He chose to demonstrate his observations on gyroscopic force, coming to a series of false conclusions on gyroscopic motion. The false conclusions this is taken from the actual report about this. These Royal Institution lectures used to be broadcast after the event. His weren't. And the reason was he came up with false conclusions. That's usually weasel words for he gave or performed an experiment which we can't explain. Now, there are mathematical equations which appear to explain it, but it uses mass and acceleration and gravity and so on in those equations. And since they're not understood or defined properly, you've got to ask whether the mathematics really works. And the scientists were so uncomfortable with this demonstration that they prevented it being sent because it was false conclusions. These can actually be seen on the web at gyroscopes.org. But here's an opportunity to analyse gyroscopic motion from a new physical standpoint, and doing so may give clues to defeat gravity using materials science as well as physics. The offset of the atomic nuclei in a spinning gyro may be many times stronger than that induced by Earth's gravity, and of the opposite polarity, because here the outer part of the gyro is more positive. It's the positive end of the gravitational dipole. The experiment suggests the gyro becomes more strongly influenced by cosmic attraction than by the Earth. Watch this. Have we got sound?
I'll balance that, first of all, like a seesaw. So there is a balance point. When I take this out here, of course, then the balance point is upset. It should dip down. We know that given the opportunity, it's going to do this if it can, but now we've balanced it, and we've balanced it about its centre of mass. So if this gyro transfers its mass centre to the pivot, it should stay balanced. Question is, will it? Let those who say I cannot make a body appear lighter than it is, come and pull holes in that one.
Now, what I'd suggest here is that using the electric universe model, there's an opportunity for mathematicians to apply the electric universe model to try and explain that, because this gyro appears as a positive charge, if you like, in the presence of the negative charge of the rest of the universe and the negative charge of the Earth, and it seems to be more strongly influenced by the rest of the universe. Maybe this is why you can use gyroscopes for inertial guidance. They tie themselves to the rest of the universe. And also with these experiments, which show an apparent loss of weight, they may be better understood using the electric universe approach. So, electrogravity. The path since Faraday to the discovery of the electrical nature of gravity has been lost in the 20th century by a return to mathematical mysticism, assisted by computer-generated virtual reality. The path is regained, as Peter Modell, who I think may be here in the audience, he writes in his book, Making Sense. By describing carefully our experience of processes that deliver meaning, we can arrive at an understanding of what is involved. The intuition of the experimentalist Faraday should have carried more weight than later mathematical speculation, because he had the experience of electromagnetic processes that delivered sufficient meaning for the invention of the electric motor. Electric currents in plasma naturally form repeated rotating patterns of matter from galaxies to stars and rotating weather systems on Earth. Science needs to be simple. Resonant orbital systems of charged particles at different levels of scale within the atom may account for the nuclear force, magnetism, and gravity. That is, one force to rule them all. The electric universe suggests a repeated pattern of electric forces organising matter at vastly different scales. On the galactic scale, it's the long-range electromagnetic force due to Birkeland currents that dominates. Plasma cosmology empirically duplicates the galactic rotation curve in detail, and radio astronomy has confirmed, very recently, the spiral arm electric currents. It's the electromagnetic forces and the concentration of electromagnetic energy in the galactic core that gives rise to an apparent gravitational mass equivalent to billions of stars. There are no gravitational black holes. As you saw, it's repulsive inside an object. At the stellar and planetary scale, molecular forces form stars and planets and induce a weak gravitational field with the sphere of influence limited by nearby bodies and the repulsive force of the matter in the rest of the universe. By making earthly G a universal constant, we compute invalid masses for all other bodies. Being born in the same electrical discharge event inside molecular clouds, stars and planets will have much the same initial composition and structure, Sun included. Stars do not have a thermonuclear core because they too have Markland convective. I won't go into detail here. It draws the matter in over a vast volume. And all of the heavy elements end in the core. So their radiant energy is due to reactions at the surface in the glowing ionosphere, driven by electric current from the galactic circuit. So this is an extension of Ralph Jurgen's model. The output of stars is not solely due to electrical input. There's something else going on. There are obviously nuclear reactions. So the complex beauty of the non-expanding electric universe is the result of electrical matter resonances and a balance between electrical attraction and repulsion at very different scales. Having a real physical model of the fundamentals, mass, energy, and gravity is the path forward. Looking back, it shows mathematics is a discipline, both ancillary and subordinate to natural philosophy, as physics was known before the 20th century. We are not within a grasp of a theory of everything when the real meaning of the symbols on the board are a mystery. We are not a few percent contamination in a dark, unknown universe. Obviously, the architects of the electric universe were far more than mere mathematicians. The electric universe shows more clearly where the real mysteries of physics lie, in the ultimate nature and origin of charged matter itself and the electric force. As Etienne Klein and Marc Lachaise-Ray wrote in their book, The Quest for Unity, the telltale sign of a unification in depth is a more complete understanding of of elementary objects and a wider reach to other fields and objects of physics. Welcome to the real adventure. Thank you.
Kills over 100 illness-causing germs and viruses. Lysol, what it takes to protect.
Good afternoon, everyone. This is the mini Ice Age rundown from January 10th to January 18th, 2018. And as I talked about in previous videos, look for the food riots to start in smaller countries first. And here we go, Sudan. Bread riots. Protesters killed as the government decides to stop importing grain, leaves it to private companies, which then double the price. Snowmageddon in Switzerland. Over 6 feet of snow has come down. The once in a 200-year flood in France again. So that's twice in 2 years that the once in a 500-year, once in a 200-year flood has arrived. World Meteorological Organization. Stratospheric aerosol geoengineering is now a new type of a cloud. BBC changing its tune now, shifting into telling us previous blizzards are normal, and it's surely going to happen again. Time also shifting gears, telling us about the bombogenesis, that it could make 2018 the worst winter in the U.S. Gee, I wonder if they're preparing our minds for cooler conditions to come. University of Alaska Fairbanks telling us Alaska was ice-free during the full glaciation. When we look back in time, the medieval warming period warmer than today, and the little ice age, so let's compare those. Alaska was cooler when the planet was warmer, and warmer when the planet is cooler. So what's happening while our planet's cooling? Alaska's getting warmer, yet they're trying to say it's all global warming. 1697, one of the coldest winters that the colonists endured. What it turned into? Witch trials. They had to blame somebody. There's a direct relationship from cold and witch trials. Let's take a little step back in time. Prince Charles gave us 100 months to avoid the tipping point, and now he gives us 35 more years. What other failed predictions have there been? Oh yeah, sea ice would melt by 2016. I guess not. Antarctic sea ice increasing above last year's levels. And the temperature departure from normal, where have I seen that one before? Oh yeah, the modern minimum temperature reconstruction map. Slurpy waves on the East Coast, and the Google trends for mini ice age and grand solar minimum on the rise. Scientists predict a mini ice age hits the UK by 2030. Well, that'll be a global event. And even at this moment, our infrastructure copes with the cold in the Northeast, frozen pipes, nuclear power plants unable to receive power down perfectly good lines with no explanation. Garbage piling up that's becoming a health hazard in New York City. Look back in history, decline in agriculture, and the number of wars increased 41% during the cool time. Oh yeah, they forget to talk about population decline. Wolf minimum decline, modern minimum decline, modern minimum and Dalton minimum decline. Global temperature anomalies, Ice Age Farmer giving us this. Russia, minus 70 on the thermometer Celsius, but the news only reporting minus 60. Speaking of news anomalies, you've been told it is record cold only in the United States. Well, let's take a look at the rest of the Northern Hemisphere. In the UK, you're on tap for Category 2 hurricane force winds blowing through today and tomorrow. Indonesia, price controls on rice. Domestic price warnings, Sudan, Sri Lanka, Myanmar for rice. Poor man's fish tripling in price in Malaysia. Recommended rations in Zimbabwe not enough. Knock-on effects from regional shortages pushing prices in Korea. This will be regional, and I do believe prohibition could be in the works again to try to save grain staples as we intensify into this grand solar minimum. Disease is rampant during grand solar minimums in human populations. You know that's going to knock on right into the animal kingdom. Food price rises in South Korea, culling flocks. We're going to be reduced down to growing food in these areas of the planet, and this is going to turn into a global knock-on effect. And we're not talking about this right now.
So it's Monday the 5th of February, and I'm currently looking east towards the moon, which rose a short time ago. From my previous home location, I was never able to see the moonrise.
Good evening, folks. Over the last week and a half, as we've seen an amazing amount of seismic and volcanic activity confirming the trends that we've been watching that underscore the importance of preparing for the grand solar minimum. These are the signs, and they continue to ramp up, of the galactic cosmic race. But we understand that now because we've been discussing it for some time. For example, here in September of last year, we're already talking about volcanoes and our grid teetering on the edge. And if I'm going to use some pretty strong language like that, then I better hold myself accountable. Now I stand by what's in that video, and I think it does stand on its own, but it speaks mostly to sort of an exotic, catastrophic event, albeit increasingly likely. But so too, just has this recent cold spell in the US, and we're about to have another one, offered some insight into the fragility of our grid. From South Carolina, where SCEG asked customers to curb their usage, but nonetheless set a record demand days later. Hold on, folks, there's a lot more of these. Let's go to Duke Energy Carolinas for North Carolina, which also set a record in energy use. Chief Transmission Officer Nelson Peeler indicating, quote, "Last week was bitterly cold in the Carolinas. Extreme temperatures drive record usage, since the majority of the energy we use as consumers is for heating or cooling our homes and businesses." As well, the North Arkansas Electric Co-op exceeding our record peak electric demand and indicating this type of weather extreme is the most severe test for electric distribution systems. It's like a nuclear stress test for your heart. Everyone should have a plan B during times of extreme weather. Over to the Tennessee Valley Authority, where they also hit a record energy use on the power grid. Randall Abel, manager of engineering and ops, says it's cold. We experienced a short 30-minute substation outage in the Woodson Ridge, Abbeville area as a direct result of the cold temperatures. High loading on several lines caused what's called neutral current unbalance. It trips the substation offline. It's a rare phenomenon, he assures us, that can happen if the load is not equally distributed among power lines. Remember that. So here's another example of the grid going down when it's coldest, when you need your heating most. Now, over in Texas, well, the grid's fine, but that's because that grid is built to power every single mega air conditioner in Texas 24 hours a day throughout the summer. So the actual indicator that this was a record winter event comes down below, where it indicates this is the first time that generation demand during the winter has equaled something like we see in August in the heat of the summer. Similar story in Florida, where they have a very resilient grid, but had the third highest usage ever on record due to everyone flipping on their electric heaters. But then energy providers in Louisiana and Mississippi reached peak power capacity, putting communities in the area of losing power during extreme colds. The new record, 32,000 megawatts, the highest peak for a winter increase compared to 23,000 on average. There was a public appeal announced to conserve energy, and even notwithstanding that, many providers were alerted that some load may have to be shed in order to stabilize the grid, which means turning off your power, again, when it's coldest. Have a plan B. But hopefully, as we move north, more people will be heating with gas or even wood stoves, right? Hopefully this trend doesn't continue. Let's keep moving north. In DC, over the course of a cold week, 3 peak records were set. The whole PJM interconnect there managed by one company and accounting for 65 million people. And then turning to New England, where ISO New England actually offers more data than most companies, even real-time sort of streaming data about the performance of their grid, which is great. We'll get to that in a second. The problems they faced included, as we see here, the Pilgrim nuclear power plant being taken offline during the weather, the cold bomb, which means from their perspective that their generation is going offline when demand is hitting its peak. Not a good sign. Infrastructure failing. In fact, so shaken was ISO New England by the bombogenesis, the cold weather, that they released this special operational summary detailing how that was impacted and the extent, as you can see from these slides from that report, to which the cold was extreme. Boston particularly is called out here as really extreme temperatures that put an extreme demand on the grid, on the generation capacity. Looking here, and this is perhaps the most interesting aspect of the report, at the generation mix before and during and after the cold snap. Now, I just want to point out that it looks like nuclear generation goes down, but that's not actually true. Nuclear power plants are online and just generate a constant amount. And so what actually happens here is that the total generation is increasing, and so nuclear goes down as a part of that. But what's more substantial here is the drop in liquid natural gas as a component of the generation. Look at it, drops from within 2 weeks from 38% to 26% and then to 19%. Now, this is a precipitous drop-off. Why? Well, they actually explained that as gas was consumed and reserves were quickly burned through, the spot price of gas rose so considerably that it became uneconomic to use. And so it was cut out of the equation. We switched over to coal and oil in the cold snap. I'm going to leave a link to this report below, as well as a link to this blogger who's been covering in great detail and very effectively that situation in New England. But I will tell you that this was no surprise to ISO New England, because the very next day they released this analysis of operational fuel security, detailing that supplies of natural gas are not adequate to meet the growing demand in the New England area, and that indeed there would be rolling blackouts as soon as 2025, which means in reality much sooner, if something wasn't done. And so they released this to spur discussion. This is an active warning here from the source, from the horse's mouth. And the way that played out also was illustrative of what happens when there's an extreme demand and a lack of supply on an economic good for which there is no substitute. You know, we talked about that before with respect to food. You need food to survive. And if you run out of food, it doesn't matter what the price of anything else is, because there is no substitute. And the same thing is true here. When you need natural gas to heat your home, to stay alive, you're willing to pay. Look at the departure from the market price here in Massachusetts, which we talked about, Boston being very cold there. That's the spot price. That's the effect. It's non-linear. And that's what it means when they say as gas became uneconomic. So let's recap. It gets cold. Your nuclear power plants are going offline. The spot price of your primary fuel jumps through the roof. You have no choice but to fall back on coal and oil, which you are immediately burning much faster than you can replenish. Prices for electricity on the secondary markets are 10 times what they should be, so you have nowhere else to go. No wonder they're worried. Shouldn't we be? Now, is this a unique situation I'm describing in the United States? Are we just hyper-focused on the US grid? No, we've talked before about the German grid requiring interventions every day. And we mentioned this before. Let's look at China. Let's look a bit deeper at China. Here we see that going into the winter, there was immense logistical scrambling going on, trying to get supplies of natural gas to where they would be needed for generation and for heating. Now, despite that, China, who has no problem burning coal, they have no reservations about that, is still experiencing shortages of coal. And as evidence of that, their thermal coal futures hit record highs on Monday. Now, this is just a couple of days ago, January 31st. A joint report issued, "We are facing pressure due to tight gas and coal supplies, and we are warning of potential heating and electricity shortages as blizzards continue in central and southern provinces." So similar heating and electrical shortage warnings coming out on the other side of the world as well. And understandably, if they only have 2 to 3 days of coal on hand and natural gas supplies are tight, this is a heating problem for China. And I'm not going to belabor this. The situation is similar around the world. We've checked in many times in Puerto Rico where the grid is still down. And I'll also include a link below to this just as a bit of context, a flashback to the worst ice storm in American history, which left people, while it was exceedingly cold, without power for weeks in 1998. These are fragile systems, and as the grand solar minimum intensifies, so too will the stress on them. And so, stepping back, this is yet another avenue of thought that leads us directly to the conclusion that we must all immediately start taking steps to ensure our own security and ability to create our own food and stand up whatever systems we need to protect ourselves and our families in the times ahead, because the existing infrastructure, from the crop losses we're seeing to these near misses with grids, these infrastructures are failing, and the time is now. If you've not already started making motions towards self-sufficiency, please start now. You can find all sorts of resources helping you to do this and information about the grand solar minimum on this Ice Age Farmer channel and on wiki.iceagefarmer.com. And feel free to reach out to me, iceagefarmer@gmail.com. Let's go build a new reality together.
Hello, this is Tony Heller from RealClimateScience.com, the climate guy setting the record straight about climate. This video is titled Goldilocks and the Three Planets. It's a story about superstition among climate scientists. This is an exhibit on display at the museum at the National Center for Atmospheric Research in Boulder, Colorado. The graph is taken from measurements of ice cores from Antarctica. It says carbon dioxide and temperature hand in hand. One of the key findings from proxy data is that global temperature and atmospheric carbon dioxide are closely linked. They typically rise or fall together. Throughout Earth's history, changes in carbon dioxide have produced changes in global air temperature. So what they're trying to convince visitors is that the historical record of ice cores shows that as carbon dioxide changes, the temperature changes with it. So if we go back 800,000 years ago, we see carbon dioxide goes up, goes down, goes up, goes down. We see the same thing in the temperature record. Temperature goes up, down, down. So now let's go back 140,000 years ago. Carbon dioxide goes up, carbon dioxide goes down. Temperature goes up, temperature goes down. This was the peak of the last ice age 20,000 years ago. What could possibly be wrong with this theory? Well, let's take a closer look at the right side of this graph. There's a huge spike in carbon dioxide, but the ice cores show no spike in temperature. In fact, temperatures are much cooler now than they were 120,000 years ago. And satellites confirm the fact that there's been no change in Antarctic temperature as CO2 has risen over the last 40 years. So if CO2 drives the temperature as they're claiming, why aren't we seeing the same spike in the temperature graph? Let's take a closer look at that now. This is Venus on the left and Earth on the right. Both planets are about the same size, but Venus is too hot, and as Goldilocks would say, Earth is just right. So what climate scientists would say is that Venus has 95% carbon dioxide, and Earth has much less than 1% carbon dioxide. That's why Venus is so hot, and Earth is just right. But let's do another comparison between Earth, which is just right, and Mars, which is too cold. As I said before, Earth has less than 1% carbon dioxide, but Mars has 95% carbon dioxide, just like Venus. So Goldilocks is a little confused now. Both Mars and Venus have 95% carbon dioxide, but one is too cold and the other is too hot. So maybe it's not carbon dioxide driving the temperature. What could it be? Goldilocks wants to come back to Earth where the temperature is just right. This is the top of the Grand Canyon, where it can be very cold sometimes. And this is the bottom of the Grand Canyon, where it can be very hot. Goldilocks wants to find the place halfway down the canyon where the temperature is just right. So why is the top of the Grand Canyon cold and the bottom hot? Isn't the amount of carbon dioxide the same in both places? Well, the difference is atmospheric pressure. The atmospheric pressure at the bottom of the Grand Canyon is higher than it is at the top. This is the ideal gas law, which real scientists have known about for a very long time. What the ideal gas law tells us is that as pressure goes up or down, temperature has to go up or down with it. So the bottom of the Grand Canyon has higher pressure, therefore the temperature is higher. The top of the Grand Canyon has lower pressure, therefore the temperature at the top is also lower. Venus has very high atmospheric pressure. Mars has very low atmospheric pressure, and Earth's atmospheric pressure is just right. So even though Venus and Mars have 95% CO2, they have very different temperatures. The difference between the three planets is atmospheric pressure, not carbon dioxide. Why does Earth have a lot less carbon dioxide than Venus and a lot lower atmospheric pressure? Let's go back to the Grand Canyon to find out. This is the Kaibab limestone, which forms a very thick layer at the top of the Grand Canyon. The chemical composition of limestone is calcium carbonate, CaCO3. Limestone forms in the oceans. Huge amounts of carbon dioxide have been pulled out of Earth's atmosphere and deposited in limestones on the sea floor. If we didn't have oceans on Earth, our atmospheric pressure and carbon dioxide levels would be very high, just like Venus. And as a result, our temperature would be very high too. So why does Earth have oceans and Venus doesn't? The reason is very straightforward. Venus rotates very slowly on its axis. The Venusian day is several months long. So one side of Venus faces the sun for a very long time. Imagine how hot the temperature would get if you had an afternoon that lasted 2 months long. So because of the very long afternoons on Venus, the oceans just boiled away into the atmosphere. What are the two things that climate scientists don't seem to understand? One is that temperature is driven by pressure. And the other thing that climate scientists don't seem to understand is that in the historical record, temperature changes precede carbon dioxide changes, not the other way around. One of my degrees is in geology, and one of the first things they teach geologists is that as ocean temperatures increase, the solubility of carbon dioxide in seawater goes down. Thus, this drives off carbon dioxide into the atmosphere. So what the ice core record shows us is that Earth's temperature goes up and down, and then CO2 levels in the atmosphere follow it. They don't lead it. That's why this big spike in carbon dioxide caused by burning of fossil fuels has not produced any change in Antarctic temperatures. So are climate scientists really this clueless that they don't understand the basic concepts of chemistry and geology? Well, apparently the answer is yes. But as is always the case, this story gets much worse. This graph is from a children's book made by Al Gore's close friend and associate, Laurie David. The graph in this children's book is completely fraudulent. Look what they did. They reversed the relationship between carbon dioxide and temperature. Note that this graph is flipped from the NCAR graph. They have the present on the left and 650,000 years ago on the right. What this graph shows us is that carbon dioxide in red leads temperature in blue. This is completely fraudulent. It's the exact opposite relationship of what we actually see in the ice cores. Now let's go back to the exhibit at the NCAR Museum. Note that they have a little disclaimer in here. They say, sometimes a temperature change can come first. Well, that's very dishonest. It's not sometimes, it's all the time. The graph below this disclaimer shows no point where carbon dioxide leads temperature. The entire graph shows temperature leading carbon dioxide. The spike in carbon dioxide at the end of the graph has no corresponding spike in temperature. Antarctic temperatures are much lower now than they were 120,000 years ago, yet carbon dioxide levels are much higher now than they were 120,000 years ago. The only empirical evidence they have that carbon dioxide drives temperature is massively altered graphs. The U.S. has by far the best and most complete temperature record in the world. The blue line shows what thermometers actually measure for U.S. temperatures. There hasn't really been any warming, but no massively alters the temperatures they cool the past to make it look like the U.S. is warming. And NOAA has done exactly the same thing in the Arctic. They've massively cooled the past to make it look like the Arctic is warming, when in fact it was just as warm in the Arctic in 1940 as it is now. Goldilocks and Toto agree. Climate science isn't just right. In fact, it isn't right at all. It's rotten to its very core. Visit Toto on the web at realclimatescience.com. He's been pulling back the curtain on junk science for a long time.
Yep, I should actually have a volume control that really blasts this thing, and I can adjust how big a cricket's is, how loud the noise is of the crickets. Our silence to do the right thing and understand how to do the right thing. And really, this week was pretty interesting, and I appreciate all of a sudden I've had some feedback coming back about what I do or what I'm not doing or whatever. I appreciate all the discussion because it helps me think about things. But what did come really clearly to me, I have to just put this out there. It's kind of universal. You can't really, when you listen to what I'm telling you, you can't take what you thought you knew, what you thought you've learned, the determinations you think you've made or that you have made that you thought were right. You have to, as I've been telling you, you got to put everything in a possibility and a probability or plausibility. You got to put categories up. Things that I tell you, the way I tell you, sometimes more complete than others, you necessarily must stick them in their own category without judging that or refiltering it through your understanding. And I'm becoming more and more aware of this problem. And you cannot. It's very important. You can be book learned, but you can't be. You won't necessarily be experienced, born to do things and do correctly. I can sit down like I have in the last few days with the few people that have approached me. All in earnest, we're trying to figure this out. Can't quite get a handle on what I'm doing, and yet I can sit down and explain the forks in the path that they've accepted that were not true, or the assumptions and presumptions they put upon what I'm saying or what they think I'm saying, as put through their filters. I can fix those things. That then orients their mind. It's really a deprogramming. There's a deep deprogramming in what's going on, and it's pretty fascinating to watch and listen to. And it really does it's an obstacle to us that we may not be aware of. And I'm kind of out, literally, behind a woodshed. It's literally, I don't have that many people to interact with. And frankly, no one really seems to be interested. And that's okay. I got enough work. I got enough things we're doing. And I tell you, I come here every week to tell you how we're doing it and that it's going on. You just listen to what I'm saying. Things do happen in the right direction. But it's because we're out there working with people that have seen what's going on. They realize they don't have to understand everything, but they trust, at least when I'm working with those people, they trust that what I'm going to tell them, and they quickly find out it's true. What they can do to catapult themselves into a better place quickly and start to become even more effective. And it's an ongoing work. It's not something that you can just say, I know it all. There's lots of problems that creep in once you finally get involved. They are real-time problems that have to be resolved, but again, it's the spirit in us, the people I work with. We're here to, first of all, make sure everyone's got the right education on stuff, on what's really happening, how we're being blindsided, or how to see the transparent, all this stuff. And trying to find ways to communicate to people. Sometimes I may not do so well that way, and I don't think I do so bad. It's just you got to be willing to listen to what I'm going to say. And there's not a lot of fluff behind what I'm saying, and I don't do much humor, although I'd like to. Off the radio, I think I'll look for anything to make a joke, but not to make it frivolous. But there's lots of stuff in the world that's pretty funny. In light of what we're facing and why I come here and why people listen, there's a serious problem. And I see it's all, my thought is, not that anything's all, a major part of this is our improper perception of what's happening. Our attachment. We are really like to put millstones around us, and then we try to crawl around to try to get effective once we got all these millstones put on us. I'm talking mental millstones. And as I think about that, the mental millstone, maybe the title of the broadcast, but as I remember that, for some reason, it triggers that I need to identify the broadcast as BTWRLM 252, I think is this week's broadcast. For the content, the broadcast, you get the links whenever I ever get to them. We'll try to get to them pretty quick. We put these mental millstones in us, and then we think we can go around the world pretty quickly and get things done. And anyway, so without belaboring this, and I don't really want to talk more about it, I appreciate, again, the feedback I got this week was pretty interesting and fun. Serious, because we need to orient ourselves into proper thought. And then hopefully the resolution really comes out now that there's a better sight, a better understanding of how this really kind of works out without the baggage we would come, or millstones we put around our neck on how we think we're understanding what I would say. In application, that path is a lot clearer. And so I would caution everybody who listens to this broadcast who thinks they know what they think they know and puts that on what I'm saying, you're doing yourself a disservice. And you can disagree with me on that, is fine. That's up to you. I can't force it. I don't try to force anybody. I do want you to, I certainly would hope the best for you better than yourself, apparently. When you dismiss what I'm saying, or you condition what I'm saying, or you think you've understood what I'm saying, and that you come to a conclusion that I'm incorrect. My thought, this last few weeks, not just this week, but the last few weeks it's been coming around. There's not a clear understanding really of what I'm telling people. So I'm going to, as I do, I try to work on how to best approach this and better communicate to people. And again, it's ongoing work. I actually don't do so bad. And I want to thank Frumpy again. It was kind of an interesting chat we had weeks and weeks and weeks ago, I guess it was. And he had a question. He had an earnest desire to understand something. In a few moments, we were able to work out the misapprehension he had on a particular subject matter. So it's just a matter, I think, of the really settling down and really focusing. That's what I tell you, folks. It's so important. If I can reduce everything down to some of the problem we have is there's just too much. Reduce it down to your problem. Find a question, or earnest question you have, and seek the answer in earnest, not that you go impose upon the world what you thought it was. I think we go a lot quicker. For my part that I hope I'm playing, anybody who dismisses what I'm saying or has an argument with me, I can almost guarantee you have a misapprehension of something, and you're imposing your own prejudice, which I see as a prejudice. It's your thought that you know something that I was saying that you thought was right, that you don't understand that's not. And again, it's not to the point that I'm saying I know all. What it is that I have not been shown wrong, and I don't mean about people that might come along and talk with me. I'm talking about in the proof of our experience of what we do to address the wrongs around us. There's not been any wrong. I mean a wrong. I don't mean just maybe an error that you need to fix. I mean a wrong. There's not been a misstep, if I can say it that way. There's not been a jeopardy caused on anybody. And then, most importantly, there's been advancement into the better. What we can see was abandoned, and what was thrown down in us as people, what was destroyed in us as people. We surmount all this nonsense, but we can only do it in a small way, and it seems to be a big proof for people. Well, what have you done? As I was talking to someone last night, well, what we do, we can't promote. We're not in the thing we can promote. He wants to, well, let's promote this. I said, well, there's nothing to promote. It's responsibility and action. No one really do it. And I say no one, but there's very few that really want to do that. And we can't pre-promote. We can't promise anything. Because literally, folks, we're in this war where anybody rarely recognizes it. And I guess it's a graded war. I guess you can say it's a mini battle or a major battle. Folks, we're just in a problem that we need to resolve in so many areas. And so for what I talk to, I can't guarantee to anybody what I'm telling you will work because we're having to fight the enemy. You go into war, you can't expect a guarantee to win. The only thing you can do is persist to fight against the oppression. And so I've come up with, looking at lots of things over many decades. It's kind of funny. It's not funny. When I say funny, it's disappointing in some regard. But it's funny that people see old information as new, and they regurgitate these things. And so the things that it's like the 30-year recurrence. The revolution is the 30-year recurrence of bad information, or the cream that rose to the aristocracy top of the bad information that gets regurgitated about every 20 or 30 years, typically 30. And I'm hearing it again, and I'm saying, I moved away. I didn't run from anything. I moved aside all that nonsense to give me a better view. I'm here. And today like I said, there's not many mistakes that we make that are so bad that we can't correct them if we find that they are a mistake. We're pretty methodical about how we set out to move forward and what we move forward on. It's all based on really the facts and condition. Every condition's different. Everyone you meet makes a variable. It's really kind of a fascinating observation, but you still have to move forward. And again, you're not going to move forward. You want to fight with me, you're pitching the wrong fight, and it's going to waste time for everybody, and you're not going to be effective. I'm not here to fight with anybody. I'm here to give an insight. I'm here to expand the comprehensive apprehension and the engagement level. And first of all, that seems to be the problem. The actual engagement is lacking. There's lack of experience in what we're doing against a formidable foe that requires that you be active. They push that requirement in international law to the limit. So I don't know what more to say. My only hope, is that you listen to what I'm saying, you hear what I'm saying, however that works, listening and hearing and listening. You do it both, and then you take in earnest, not an argument with me. You find out what I'm saying that you can go prove is correct. Don't assume upon me things that don't exist. Don't force my observations into what you think you know. Because as I talk particularly with people on their problems with what I'm saying, it's a misunderstanding that they have about what I was saying. And I find that it was because of a misunderstanding or a misapprehension or a misstudy, misresearch, thinking that what you researched was really the relevant or important thing, and it actually isn't. It's not in play. And then no expectation. This is the other problem. People have a real problem with that. It's like it's a failed proof. Then it's you're talking nonsense. How can you walk into something without having a proof that what you're doing is right? Well, that's the battle. There is no spoon, folks. They tell us, like I came up with a chat. I don't know if anybody understood what I said in the UCY chat. There is no spoon, folks. This is what they get you to perceive, and they've got us perceiving all kinds of stuff that ain't so. And we attach it to ourselves. And then we think we because we know something, like I was talking with someone last night, well, we got to promote this. And I said, I don't know the product that there is to promote. This is not a product we can promote. This is us taking responsibility. That's a variable. There's no proof in all this. And that scares people in here. And so maybe let's touch last week, because I thought I was doing and thank you for everyone that tuned into it last week and did all the downloads and all that. Appreciate all that. But I haven't gotten any response about that. Now, I didn't have a full amount of information, so I figured I'd have some substantive response and say, well, you got this wrong and this wrong, but nobody responds. And I don't think I had it so wrong either, so they're not going to step up. What's there to step up to in that regard also? And if someone had it wrong on the side that the people that I'm saying, hey, you got to get it better, they're not going to necessarily contact me. They're not going to admit they've got a wrong perception. They're not going to even contact me to tell me how I got it wrong. Because then they're going to have to face what I would ask, because I'm now wanting to know about what they're doing. Why are they going down that track? One thing I can amend from last week is I didn't know what court they were going into. It sounded like from a 2-second statement by the guy who's their attorney on the Bundy issue for the quiet title action. Apparently they are filed in the state court, but that made even their water claim even worse because you don't quiet title on water. And so there's a misunderstanding, and I don't want to condemn that. I want to expose there's a better way to approach it. I want to expose that you need to approach it that better way. Otherwise, the other side takes advantage of your ignorance. They take advantage of how you misspoke. They take advantage. I was telling somebody yesterday. If you don't, as I talk to these land disposal laws, if you don't speak inside the language of the law and you allow someone to bring language in that doesn't belong there, you've just diminished your grant. You've diminished your property rights. Because the one who's bringing it in usually is an authority that's going to take that diminishment now, which they can now regulate because it now has a servitude on it, and they can regulate that servitude. In the case where I just talked about, so that you know it's not so esoteric, it was the simple word. We would just think the operator within a mining context. It's the operator of a mine. Most miners don't understand that they're not an operator. And just to give you a basic definition, which is not complete, but for this point of definition, an operator regarding mining is really a contractor to the United States government advancing a project or plan, a demonstration that the government has set up. You're the worker in a project. You're not the grantee earning a livelihood with a possession. And they throw the government agencies and all the forms will throw an operator in there, all the regulations throw operator, and the miner says, okay, I'm an operator. Doesn't stay true to the language of the grant, which he's a grantee. You're not an operator. And so, as I was talking to someone last night, this simple little attachment that we do to ourselves in the mining community, and you'll do this in your land disposal, whether you're a farmer, a rancher, or your appropriation for water rights, even your use of the highway, you attach to yourself the thing that the government needs to regulate, and you think that that's okay. And so this isn't a reference. It seems so simple, this word operator. What harm can it do? It's all the difference in the world. That's attached to a facility as well. And the facilities underneath the law, the statutes can be regulated. They're not talking to you. They're creating this, as I talked about 2 weeks ago, the straw party, the straw facility. They take your application that you thought you needed to fill out because you didn't understand what was going on, and they convert it right in front of your face, and you don't recognize the conversion. And I've pointed this out since 2005 to people. I've shown out, well, you filled out for this permit, and now look what they did when they hit the internet. The internet shows you as a facility subject to their jurisdiction. As a man, when you filled out that application, are you a facility, really? And they said, well, no. I said, well, there's your straw party that they have jurisdiction over that they've now converted you into. You're dealing through that. And so this is the same condition. They make you something that you're not because you didn't know to stay away. Typically, it requires these applications. The applique, you stick it to yourself. It's all the self-inflicted wound. And so when I talk with someone who has misunderstandings about this, these simple little things, actually, and I can point out more detail, and if we went on further with this, there's a couple of other conversational terms I can show that are within the context of mining documentation that they want you to fill out. How you change your status and then how you become subject through that when in fact what you should have done is been true to the language of your grant, true to the language of the power of your exclusive possession, even to every landholder where you have a patent already there for the evidence of that, that you give up your rights. You are diminished. You are not a status that you're not until you agree. Or these presumptions in law are killers. You have to go after them, but it's not that hard. Lots of people go on too far. What I've said before is simply stay with the grant language. If you're only a grantee, don't take on any more color. Don't let them put more onto you. You're not an operator, not a contractor. You're not any of this. You're not a laborer. You're not a laborer underneath the Title 29 of the Federal Code. You're none of these. You're simply, again, this operator with occupancy is another one, because of what they did on that for a miner and anybody who else has a land disposed to them. They have an occupation on that land. It's not occupancy, but the regulation talks to occupancy like you have a house and you're living there. But your occupation is actually your possession and control of that land. And so you miss these little words. You don't listen to what I'm saying. And you attach everything in your mind onto what's onto these things I'm talking about, you have diminished your ability to understand. Not a judgment, it's a fact. There's no way you can go away from that. And so it takes a little, for like yesterday's conversation with a friend of mine, trying to let him see more because it had, perplexing look on his face and had questions. It took a little bit to explain some of these examples. And once I started to straighten out the misunderstandings, the attachments of the failed understanding onto what I was saying, it starts to become more clear. I have to say more clear because I don't know, how far we go with this. You only see as far. I only see as far as I know, so I can only see more clearly. I hope at some point more clearly is way sufficient to defeat anybody who comes to attack you. And so we make sure. I'm asking you here when you listen behind the woodshed, and I really suspect in the future, if my broadcasts are ever available, all those that have been doing research in the last 8-10 years will maybe come to the terms with the fact of they learned themselves into a little box and they never really turned around and applied the things, and then they'll recognize once they free themselves of their own prejudice and they look at what I was saying, what I've been saying more clearly without that shade, without that tint or taint, I think you're going to realize what I'm talking about better. And so I just continue. I don't know what to expect from people anymore. A part of me is really disappointed, but I see more and more people getting it. They finally break through, and they take their own way. It's not even I have to direct the way. That's why I say find your own path, find your own wrong you need to make right, and then work with that. That'll give you lots of what you need to do. I repeat this over and over and over. For the few that do keep coming back and listening, you hear it. I don't know if you understand what I'm saying. I don't know if you appreciate what I'm trying to tell you. To try and focus you down. It's really in any aspect of life, it seems to me, that I look at all this, on how to deal with things in your life and deal with them pretty quickly and effectively. And I can tell you that because it's because we're living in this fabricated reality, it's really not a reality. There is no spoon, folks. Everything they tell you is sitting there as an illusion for you to accept. You don't have to accept any of it. You sit in your innocence, if I can say it that way. You can now be free to look around and say, okay, well, if I'm free, I'm innocent, and I'm free from being imposed. That's what you see in the Constitution. The freedom of association is the freedom from being imposed with an association. I can kick back a bit, at least contemplatively, and I can say, if that really isn't attaching me, then that person doing the attachment is committing really a crime against me. And then if I go from there, then I just have to go showing it, because the presumption is an authority is the authority. Why? Only simply because they have the violent power to force that upon you. You better understand you're in a different place. And it's not about what works and what don't work as a systemic thing. Like people say, well, you can't go to the courts, or what I talk about is that it makes no sense, or because if you go into the court for the answer, you're not listening to me. In fact, we talked about this last night. We're in serious trouble, folks. I don't know how anybody can expect in a system that didn't intend justice, or a change where there's no justice, why you would go and think I would be going anywhere to insist that justice would be done. And then saying, well, because you don't have that option, that you're frivolous in saying that you need to go there. No, you got to confront the enemy. I don't know of anybody that can win a battle without confronting the enemy. And I mean confronting, there's proper ways to do it. What Aikido, you can engage the enemy and use his own energy against him. That's kind of what I'm talking about, almost all the time. You find out those weaknesses that they have. I told you about the habitual beast. The government, the people in the government are habitual beasts, and they're constrained by that code. They show that black and white. They tell you that that's there to. They call it law. It's a constraint to them, and they have to work habitually with it. When you find out the Achilles heel, the tons. I mean, that's a centipede. It's a millipede. The government's a giant millipede. There's all these legs underneath this thing, and they got all those Achilles heels you can trip up. When you find those, that's where you attack. And you use that weakness against them. You're not really attacking anything. You're just showing that they can't use that leg no more. And it may take taking out a couple legs before that thing falls down. I don't know. But one or two guys, a handful of guys I work with, we're certainly going to not make much progress for people to prove to people what's going on. No, we have to go much more subtly. In fact, it's much better. As I told the gentleman last night, we can't promote because we also can't give the enemy our plan of attack. We can't show how much we're doing. that's what they'll turn their effort in that area, and they'll defeat us. Right now, the surprise attack, it's the ongoing attack. They don't even know what's going on. It's this insidiousness that we put back on, hitting all the Achilles heels we can find. And we base it on the creatures and this beast, so this happens. Listen, my email, markonthebeast@yahoo.com. How many years have I had that? We find we put the lashings to the beast where we can. The beast is just this thing that people think called government that they sit inside and use as a criminal, the criminal cover of the color of authority, but covers their criminality. Anybody think I'd be suggesting you go in there and expect justice? No, we're going there to out it. And then, most recently, within this last year, I've now come to the awareness of how to use these tools to use law, the law we expected to work. In other words, that law that was supposed to keep the peace, the one that's not being kept, and we see nothing but chaos around us and no justice at all, we insist upon. And there's things that work, like the presumptions in law, that work automatic in law. Now, people will argue with me, but that's okay. You'll see one day. Well, hopefully you'll see. Hopefully you won't be one of those that dies not seeing. Hopefully eventually, your last day, your last gasp of breath, you say, oh, that's what he was talking about. Then you'll expire. And that'll be good enough for me, I suppose, although you wouldn't be very effective. That there's things that happen automatic in law once you flick all the levers. And the obligation is, because everyone's innocent, you have to flick the levers. It's all this. That part's pretty simple. So, if you don't flick the levers right, you don't hit the combination, you don't hit the fact, you don't have the magic decoder ring that gives you all the lever codes, the encryption in the system, you're not going to get out what you expected. And then you're only going to get out what you're going to let yourself believe happen. And if you abandon the law I'm telling you makes matter of law conditions that happen, exposing those people in the government, anywhere, even your neighbor to be a criminal that they might be. You don't let that automaticness work. If you don't let that automaticness work, you have defeated yourself right there, because you're not allowing yourself an existence that will be automatic. In a way, peace is automatic when everyone's being peaceful. So this is an interesting, to my mind, an interesting way to keep the peace. In other words, we're not beating anybody up, we're not beating anybody down, we're not torturing them, nothing. We do these things that the society that we live in has agreed should be done in order to keep that peace. And the mining law is a pretty interesting originating source, because the mining law was created in order to keep the peace amongst miners who would kill themselves for that shiny gold stuff. And so start putting in context, there's a more natural sense that comes out. It's the natural sense that we weren't so cool with each other, but we have a better nature in us that we can work toward, and we can do things for ourselves. And that's what I try to bring here. We can work toward the better day that's been stolen from us. But we have to work for that better day. If we don't, that theft continues and it gets worse. There's nobody that's going to be coming in your life that's going to steal something from you that's ever going to care about you. What's going to change them to care about you more than whatever drives them? And obviously,
In Austin, it's 60 degrees with a Alexa?
Amazon's Alexa lost her voice this morning.
Tweet that you may have missed something. As with every morning show, you can find the links to everything you're going to see here below this video. We're starting with the space weather and human health aspect. The statistical correlations between space weather events and negative health outcomes are hard to ignore, but when we get direct ionospheric correlations, we begin to understand the mechanism by which this space energy has driven the correlations found in the peer-reviewed literature. HR 4796, probably the most well-studied, most photographed, and best understood dust ring in the visible cosmos, except as a testament to the expanse of cosmic mystery. None of that study allowed us to discover the massive dust belt vastly stretching around the entire system, at least not until recently. This is critical because we believe that the plasma and dust population in the vicinity of the hypothesized dark matter halos could explain much of the activity seen without the magic material, but that's presuming we can discover it. Up next, a recognition of what solar scientists have said, falling on mostly deaf ears for years. The jet stream is a long-range projector of the weather in the UK. The broader story tied together here is that the jet stream, polar vortex, and North Atlantic oscillation almost completely control the UK climate, and all are predictable years in advance based on solar activity, all pointing towards a disruption of the temperate weather in the North Atlantic this century. Next, we have Professor Egdal doing his Alphen impression and definitively finding the same types of problems with frozen in-field lines and the explosive energy of disrupting currents. This should rewrite a fair portion of space weather and cosmic science, provided anyone is listening. By far the most critical cosmology paper this week was the discovery that the Centaurus A dwarf satellite galaxies debunk dark matter theories in their orbital patterns. This makes the three most studied of such galaxies, Centaurus, Andromeda, and our own Milky Way, all sharing these patterns that do not fit the standard dark matter models. By far the biggest story overall this week in our world was the launch of China and Italy's electromagnetic earthquake forecasting satellite. We'll have much more on this in just a moment, but first, if you aren't following us on Facebook, you'll miss a lot of quick little shares, but this week we had a blowout of shared eclipse photos on our own. Looks like you guys had a great time, just like I did. Website members at suspiciousobservers.org, we are up to 16 deeper look episodes on the year. Lots of interesting material, but number 15, it's about Earth's equatorial ion fountain. Not only explains the ionospheric excitation double pattern under the day side, but indicates how young observer Ferris Wald won the New Mexico and then National Science Championships tracking solar effects on weather. He'll be at the conference again this year, and I can tell you that number 15 is well worth the few minutes. We also have our weekly podcast, Fly on the Wall, found on the premium page, and without your support, we don't get to do any of this. Now, I promised a little bit more on the earthquake forecasting satellite. Here is a rerun of the special video we did on the topic February 2nd. Enjoy. If you didn't hear the big news, China has launched my dream machine, at least 90% of it. As veteran observers know, we have an odd tangential connection to this project, and so let's take a look at what's happening in that project with some history. It actually goes all the way back to the Demeter satellite, a French satellite that operated last decade and which was used to document numerous electromagnetic pre-seismic anomalies to major earthquakes. Despite the flood of papers that used its data, it was never used to forewarn, to deliver information about those signals before the actual earthquakes. It was decommissioned, and since then we've awaited another machine to do what it did, but in a way that would be useful to everyone. Well, the new machine has some upgrades to be sure, including an electric field detector, which was one of the two things, along with an ultraviolet imager, which is not on the satellite, that I believed would indicate when the solar polar fields were acting strongly on Earth's magnetic system and could cause the major earthquakes. That was indeed the subject of a paper written in 2015. My co-authors, Dr. Jeran and Dr. Holloman, helped confirm the correlation statistically between the solar polar fields and earthquakes, and then describe the mechanism. One of the first people to ever read and review the final paper is actually a member of this project and is likely to be exceptionally knowledgeable about concepts related to electroquakes. Good sign for them. The reason he was probably selected for the review was this project indeed, which he actually started to be a part of while we were first discovering that some of the electromagnetic pre-seismic anomalies might be a connection to space weather beyond just the lithosphere-atmosphere-ionosphere connection. He was already in the planning process for this satellite, and now, today, is the day it finally launches. The mission is supposed to be only 5 years and will only survey China and nearby Southeast Asia and probably Europe as well, since an Italian group is heavily involved. But it will be turning off most of those devices for the most part around other areas of the world. It will include at least a few years of study protocols and data gathering before considering any active alert, and even so, it could be possible that the locations will be restricted and might even be considered China's private private information. Wouldn't be the first time. However, this absolutely puts this China and Italy team in the major race to be the kings of electromagnetic earthquake forecasting. For those just joining the program and don't know about some of the other notable groups in that electroquake category, one of them is the NASA and ETH Zurich team, which came out with their model results and plans to go forward in November of last year. At the end of the day, they actually came to include the two atmospheric parameters that we use in our model, outgoing long-wave radiation and the geoelectric system of Earth, although we like to use the global electric circuit as indicated by wind and pressure. For more on our model, including the background from 2015, you can go to quakewatch.net and look up at the top right. Our current model is found in the 2017 and 2018 spots just below that. While we don't have the clout of those other major groups, we didn't have the hurdles of academia, government, and policy, and we are indeed already more than a year into successful real-world forecasting. You can learn about that there too. However, there is no question that today it is the Chinese and Italian teams that stand in the spotlight. It's their day, and given their 100% electromagnetic focus, I can only predict at least some measure of success for them. And I can honestly say, I hope for that success to bolster the awareness and acceptance of electromagnetic pre-seismic anomalies as a means of realistically forecasting earthquakes. Be safe, everyone.
Doctor, I still don't understand why you have unlimited with Verizon. Why wouldn't you switch all your lines to Sprint?
Well, good morning, folks. Got to start it the same way we start the news every day. So for those who don't know, my name is Ben Davidson, and the YouTube channel is Suspicious Observers. If you Google it, you won't even get all the way through the word suspicious. It'll know what you're looking for. We do a space weather, earthquakes, and general science, space, electric universe news program every single day, and have done so every single day since 2011. And when I say every day, I don't mean we take weekends or holidays off. The Earth and the Sun aren't allowed to do that, so I'm not allowed to do it either. It got a little shaky the day my daughter was born, the day after my wedding, things like Christmas, my mama's birthday, but you know, some things are just important enough that you got to keep them going. Anyway, I want to thank Kong Pop for the shout out. Indeed, he does contribute, and we're very, very thankful that he does so. He mentioned Mitch Batros as well. Mitch Batros and Earth Changes Media have actually partnered with Suspicious Observers in the last month and a half, and so we have the very first space weather reporter now on board and looking into these same sorts of things, and I'm sort of getting his mind around to this as well. In fact, Mitch, over the years, has interviewed most of the members of the Thunderbolts Project. But anyway, what I'm going to talk about today is going to quite rapidly enter your mind as something that is belonging right after Kong Pops. It's going to be a little more specific to the sun, and it's going to use a little bit more pictures, I guess we'll say. On the one side, you have the sun and its magnetic fields. On the other side, that is supposed to be an earthquake signature, anyway. This is the headline image from a recent news release and an upcoming publication on how the solar polar magnetic fields of the sun trigger the largest earthquakes on our planet, magnitude 8 and above. The paper, the manuscript, Kong Pop contributed to that as well, and because I am not a statistician and nobody would take my statistics very seriously, I got the statistics department from the Ohio State University to do this with me, led by Dr. Holloman there. Anyway, what this is a specific set of magnetic fields on the sun. When Kong Pop was talking, you could see the bright loops that were connecting the sunspots, and those are called umbral magnetic fields. You go a layer up, and there are these fields that we'll see in a little bit called coronal fields, and those arch a little bit higher and a little bit farther across the sun. What we're going to talk about are solar polar magnetic fields. They come out the poles of the sun, the north and the south. Now, there have been many attempts throughout history to use elements of the sun to try to predict earthquakes or try to show that there's a correlation. And as we have seen with many single instances, this can be done very well. Very, very well. But in other times, it doesn't work so well. So, for example, if you were to use sunspots, you could go through a year, maybe 2 years, and be genuinely convinced that this was a dead, perfectly accurate system. And then the very next year, you look and it hasn't gone away totally, but you're very much wondering where that perfect correlation went. Same thing happens with solar flares. You know, people have tried this with sunspot numbers for decades. They've tried it with solar flares as well, and they get pretty much the same thing. Sometimes these correlations make you drop your jaw, and then other times, usually right about the time you tell somebody to go look at this stuff, that's when it stops working so well for a little period of time, and then it comes back and you're wondering what happened. Then, as our ability to watch the sun got better and better, people started using the CMEs, the coronal mass ejection shock waves. Again, we have seen this one a little bit better. Very, very correlated, and it's not just these CMEs that are fired at Earth either. They can be fired in any direction from the sun, but when they get to Earth's distance away from the sun, these tend to be very highly correlated. Then again, of course, over the past week, we had a ton of sunspots, north and south. We had a flurry of M-class solar flares. We had a flurry of coronal mass ejections and geomagnetic storms and high-energy proton flux and electron surges. In fact, if you looked at some of the magnetograms, it looked like one of these coronal mass ejections that hit our planet last week temporarily for about 2.5 hours flipped the polarity of our magnetic field. That would be the GOES magnetometer. But again, no big quakes. We had literally sunspots, flares, and big CMEs hitting Earth with the geomagnetic storms, and yet we didn't have these big quakes. Why is it that sometimes we have these things going on and sometimes we don't? Why do these correlations appear to be perfect sometimes? Another one that they look at often is geomagnetic activity. I mentioned that with the storms, and COPOP did as well. People have tried sunspots, they've tried flares, they've tried CMEs, they've tried geomagnetic activity. Isolated, all by themselves, not looking at the biggest picture, not bringing everything in, but trying to isolate earthquakes against one other thing. Well, the problem with these so far has been that either their N is too small, and that means the size of the study. Either they're looking over just a few short years' time, or they're looking over one solar cycle, which probably isn't going to be enough, at least to convince me or most solar scientists that this thing works. Or sometimes they suffer from there being a lack of statistical analysis. They're saying, look, this happened, this happened, this happened, this happened. But what you're missing is all the other things in this list or in this list that don't match up to something in the other list. You see what I'm saying? Or the other thing they suffer from is there's no way to test these things, or there's not even a hypothesis about what the mechanism for this seismic trigger would be. Well, this is why when, as I come back to the polar magnetic fields of the sun, this is why I wanted to sort of put a lot of this together. I didn't want my N number to be too small. We wanted to use as much data as possible. Wanted to have statistics, because just showing this doesn't really work very well. So I got Ohio State statisticians to do the work on the polar fields for us. Still working on how to test magnetic fields of this size, but we are getting closer to a mechanism of how this might work, and that is actually thanks to Dr. Uyen. He actually proposed the mechanism for how these polar magnetic fields on the sun are triggering the earthquakes, and of all of the proposed mechanisms so far, Dr. Uyen's is the best, and I'll mention that in just a moment. Anyway, what you're seeing here is a very, very simplistic view of the polar magnetic fields of the sun. Some of them indeed look exactly like this, but not all of them. The ones very, very close to the sun look like this, and the ones that stretch out past Pluto look like that. There's ones in the middle that come off of the polar coronal hole and ride the heliospheric current sheet. This is the current sheet that Earth dives up and down through as it's orbiting the sun. The Earth is passing up and down through this current sheet. This is what we see in the solar wind called a solar sector boundary crossing. Now, you can see how these might be interacting with Earth just like a solar flare or a coronal mass ejection. I mean, we're talking about magnetic fields out of the poles of the sun, and they start right there at its edge, and they go out past Pluto. Some of those ride the current sheet potentially right to Earth itself. Keep that in mind. Let's take a look at what some of the trends are in the solar polar fields. This is one way to look at what I call the polar field cycle, and it is on the exact same cycle as the sunspot cycle of the sun. However, there's something a little different about it we'll get to in a moment. So we're starting here, and you can see in the very first image up top on the left, we have the blue sun, positive magnetic fields of the sun, a little bit bolder. You can see the color better than you can see the red up on the top. There's about a 1 year oscillation between which poles are stronger in the sun. So go 6 months later to the image on the top right, you can see the northern fields, the negative fields, they're bolder, they're stronger now than the positive blue southern fields. Well, after it does that for about 11 years, north, south, taking turns being stronger. They reverse, and you can see down on the bottom that blue and red have switched places, top and bottom on the sun, but they're still following the same pattern. North is stronger, then the south is stronger. And this is what it ends up looking like. We end up having this thing that really follows the solar cycle, except we have a lot of things to be looking at. Now, one thing I want to mention about a different way of looking at the solar cycle. The published literature, starting back in the 50s and winding up just in the last few years, suggests that the shape of the heliospheric current sheet, the pressure of the solar wind, the number of sunspots and the position of the sunspots on the sun, the flare magnitude and the occurrence, how many flares there are, the frequency, all of these things, even when the cycle flips, it's all due to the polar magnetic fields. And as you'll notice, as these fields are flipping across the baseline, sort of like this, at the time when the fields reverse, that's when the magnetism of the poles at the sun is their weakest. But it's the time when the other magnetic fields of the sun are strong. That's when you get the sunspots, when the fields are reversing, when you get the powerful flares and the CMEs. You go to the areas here where the lines extend away from the central baseline, that's solar sunspot minimum, but it's the powerful polar maximum of the sun. And given the fact that all of space weather that we know of is dictated by what these polar fields are doing, maybe we should start to think about the solar system a different way. I mean, just picture this. You've got north-south aligned fields. And then as they flip, they've obviously got to come down through lower and lower latitudes, cross the equator, and then go back to the other pole. What do we see the sunspots do? We see the sunspots start at higher latitude, creep towards the equator, and then flip over. We see this with coronal holes as well. So, what is it about what we're seeing here that triggers large earthquakes? And by the way, you can also see that 1 year oscillation up and down, in addition to the longer 11-year polar field cycle. And that green line in the middle is actually the average of the fields. And so what is it that is actually creating the earthquake? I will go back for a moment. The analysis was simple. Most of the times in statistics these days, it's not simple. But the quote from Dr. Holloman at Ohio State University was that this is just plain simple. There is no complex factors. There's no complex math. And after I say this, you're going to say to yourself, huh, those are the factors I would have picked if I had to do this analysis. The peaks in magnetic force of one of the poles. Now, don't just look at the top, you have to look at the bottom as well, because the baseline you see is in the middle. So something down at the bottom is really strongly magnetic, just magnetic in the negative. So when you have a powerful magnetic force of one of these poles, those are the times that we're most likely to get the large earthquakes. Or when you have one of these poles reversing polarity, that is when you have a chance to have these large earthquakes and positive, negative, negative, positive. And the third factor is when the green line does it. The overall polarity of the magnetic fields of the sun changes between positive and negative. So we have the reversals in force, and then we have the peaks in force. That's it. Nothing else. I wanted to start very, very simply. I wanted to actually isolate half of the days as being more significant and half of the days being less significant, sort of turning it into a coin flip. Because you see, if you could identify 50% of the days within a given period as being significant for earthquakes, you'd be expected to get about 50% of the earthquakes, the large earthquakes within that period. But if you got 60 or 70 or 80 or 90% of those earthquakes within that period, within only a 50% window, someone might say, hey, your choice of that window, there might be something there. Turns out there aren't enough significant points along this timeline to create a 50-50 split and turn it into a coin flip. We identified 41% of the days between the mid-1970s up to 2014. We're talking more than 35,000 days. And so that's a big N number, by the way. And we're talking about 41% of those days. And we got almost 80% of the magnitude 8 earthquakes. Now you start going down to 6 magnitude, 4 magnitude, it doesn't work so well. Turns out this only works with the largest earthquakes on the planet. For those who are more statistically minded, the p-value on that was 0.0000015. But you see, the polar magnetic fields, these are really only helpful for a retrospective analysis of these large earthquakes. The polar magnetic field data is on a 3 to 6 week delay from Stanford's Wilcox Solar Observatory for reasons I don't fully understand. But so you can't really look at it and say, oh, this could be a time, because by the time the earthquake has happened, the most recent data you can see is just a couple of weeks old. I mean, it's already a couple of weeks old. However, there are things we can learn about this. You remember earlier I mentioned that when we are in sunspot minimum, the polar magnetic fields are straight up and down and they're strong. But when we go to reverse polarity on the sun and we approach sunspot maximum, the sunspots and the coronal holes begin to leave the poles and come down towards the equator, eventually flipping. You guys might remember this. It was a different color when Kong Pop showed it. This is the southern coronal hole that was present during the Japan earthquake. This was just as this field was starting to flip. Now, the reason you don't see many coronal holes around the equator of the sun during solar minimum is because they're hiding from us. They're hiding at the north and the south. In fact, there are permanent coronal holes at the north and south poles of the sun. This is where the polar magnetic fields stream out away into space rather than looping back down to the surface of the sun. And what do we see in coronal holes? Unlike sunspot magnetic fields that loop back down to the surface of the sun, these coronal holes have magnetic fields that also stream out into space towards the planets. In fact, you can track the magnetic connections of the planets to the star. This is at a free online application called ISWA, the Integrated Space Weather Application. It's run by NASA. And you can see that the planets are only ever connected to the sun at these coronal holes. They are never connected elsewhere. So, Here we have the same type of streaming out magnetic fields that we saw coming out of the poles of the sun before and riding along the current sheet. We see those same fields extending out of coronal holes, and we know for a fact that they connect directly to the planets. Well, the polar fields are nice for this retrospective analysis of major quakes, but what if you want to predict them? What if you want to be looking at these things and really being able to predict them a few days in advance? Well, coronal holes are a good place to start. There are a couple other ones that Gong Pop mentioned, and which I'll talk about in a moment, but as far as I've found, the ebb and flow of 6 magnitude earthquakes on this planet, which is generally considered the baseline for a significant earthquake, the ebb and flow of that appears to be dependent on coronal holes primarily. Now, what do I mean by the ebb and flow? According to the USGS, and indeed if you look at the data, this bears out, over the longer time scales, you will have approximately 3 6 magnitude earthquakes every week. However, it is very rare to see a 7-day period with 3 6 magnitude earthquakes. You see none, or you see one most times, or you see 5, 6, 7, 8, or they've jumped up into 7 magnitude or 8 magnitude range. It is the ebb and flow of that, which on the long term comes out to 3 a week, but on that short-term variation, it's based on these coronal holes. This is what we do every day. One of the things we do every day in the news. And it has proved very, very fruitful. Just a couple other examples like this. Like I said, this is the one that was present during the Japan earthquake. This was 13 months later to the day, the first time we have ever seen 2 8 magnitude earthquakes strike in the same day. They struck the same location, Sumatra, April 11th, 2012. The very next 8 magnitude earthquake was in February 2013. This was the coronal hole situation then. This was the coronal hole situation later that year in late May, when an 8.3 struck very, very deep under Russia. We don't have a ton of good examples with those great magnitude earthquakes because the Solar Dynamics Observatory was just launched in 2010. And you can use SOHO and what's known as the GOES Solar X-ray Imager to go back before that, but there's really no substitute for what this new satellite has taught us. And every 8 magnitude earthquake since its launch has had an Earth-facing coronal hole. More than 90% of the 6 magnitude earthquakes and above have had an Earth-facing coronal hole. Why would this be the case? Well, it could be that those interplanetary magnetic fields that are put out by these coronal holes, the ones to which often the planets are connected, that could be one way this works. Or it could have something to do with what a coronal hole is and how it presents itself to the inner heliosphere. What you're seeing here is, I took this straight from NASA's website. This is what it looks like, a side view of a coronal hole. And these are supposed to be Alphen waves emanating from the coronal hole. And without getting too technical or complex, it is generally understood that the Alphen waves emanating from the centers of coronal holes are far more efficient at transferring solar energy to the planets than are the surrounding regions of the sun. So there's another option for how these coronal holes might trigger earthquakes. There's a third one too, and this one's kind of my favorite. You know, the sun is a giant sphere magnet. The Earth is a giant sphere magnet. These coronal holes are always polarized. They're either powerfully positive or powerfully negative. So we have this central sphere magnet, and we're living on another sphere magnet going around it. And a coronal hole facing Earth is essentially taking a strong, powerful magnet and just pointing it right at the Earth and then taking it away. Pointing it right at the Earth when it faces Earth and then taking it away. When you start to think about the sun and space weather in these non-traditional ways, your mind just can't help but race. Because you start to immediately get an understanding for how the Earth and sun could be interacting so well over such a distance. Of course, the other thing we look for to judge coronal holes on a day-to-day basis is the power of them. We can actually judge how powerful a coronal hole is. And we do this by gauging the solar wind coming out of a coronal hole.
So the black lines that you see coming from the top left and connecting to the colored areas, that is known as Earth's magnetic connectivity. During the time I pulled this image from ISWA, the Integrated Space Weather Application from NASA, these were the coronal holes on Earth in color. And you can see over on the right side the speed of the solar wind coming out of them. Well, it's just fairly logical. If you've got one coronal hole blasting 700 kilometers per second wind and another one that's only blasting 500 kilometers per second wind, which coronal hole is stronger? It's quite clear. Now, I mentioned these earlier, these coronal magnetic fields. These are something else we use to judge coronal holes. By the way, everything I'm talking about right now is how do we judge whether or not a coronal hole is going to be really significant for seismicity? Well, first it's got to be facing Earth, but we also like to look at the size. We also like to know if it's trans-equatorial. What I mean by that is, does it cross the equator of the sun? That seems to matter. We like to look at the speed of the solar wind, like we saw there. But we also like to look here. This is the final factor that we use in determining whether or not a coronal hole is going to trigger seismicity. And it was not until we started including this factor that we hit that 90% mark on the 6 magnitude earthquakes. We were right around 80%. If I'm being honest, it was 79 point something before this. Not bad, but still, this is where you look. And what you have here is these coronal magnetic fields can sort of act to block the effect of a coronal hole. And so we will oftentimes see a coronal hole on the sun, and you come and you look at the coronal magnetic fields and it's looking like it's getting pinched in, or it's crowded, or it doesn't have a nice wide opening to the solar system. So this first one right there, you can see an example of both extremes. The northern positive green coronal hole is vastly open to the solar system. The earth-facing portion of the southern red negative coronal hole is entirely pinched and blocked by coronal magnetic fields. Now, we must do this day in and day out. Very, very simple. Things change. And interestingly enough, I don't have this slide here, but if you were to look at sunspot minimum, there would not be any of this undulation. None of it at all. It would just look like it wrapped around the sun like this. Why is that? Because there's nothing going on here. The coronal fields own it. There's no sunspots. The polar fields are all up and down at solar minimum, remember. And it's not until those reverse that we see these coronal magnetic fields start undulating and the coronal holes leave the poles. The sunspots start migrating towards the equator and coming in full force. And by the way, given the fact that the coronal holes, what they actually do is they literally leave the poles and do this, what we're seeing with coronal holes, these are actually the polar magnetic fields, and we have just been mislabeling them for as long as we've known about coronal holes. These are literally the exact same polar fields that we looked at before. It's just this is them in the process of reversing. Fascinating stuff. Here's another example, just so you can see we have a red negative coronal hole departing. It is trans-equatorial because it's crossing the equator, and you can see this is where some of the 3 to 4 day warnings about earthquakes come. You can see over on the other side that in a couple of days, as the sun turns, that green coronal hole, the positive one, will be facing Earth. Now, of course, what is it that we're really trying to do here? As Kong Pop said, we're trying to predict these natural disasters. And I sort of started with a question that I never really came back to, and that was a bit by design. Why is it that sometimes these things look like they are the absolute trigger of earthquakes and volcanoes and storms, and yet other times you'll say, what happened here? This was working so well. In fact, despite everything that we've done with the polar magnetic fields, that goes as well, because we had 41% of 35,000 days
there's going to be some days we identified as significant, that there were no massive earthquakes. And we only got 79% of the massive earthquakes in that 40%. So there were some massive earthquakes, and the polar fields were not significant at that time. So what is it that we're doing here? We shouldn't really be ignoring these periods where you can see it so clearly. This isn't a coincidence. This is more of dependence, cause and effect type of thing. But you also can't ignore these periods where it doesn't seem to work as well. What you have to do is you have to bring everything together. You can't just look at coronal holes. You can't just look at the polar magnetic fields. You can't just look at CMEs. My God, we got hit with 5 CMEs in the last week, and it's been one of the lower times of seismicity that I can remember. So what is it? It's looking at all of these things together, and including the planets, which I did not talk about, but which are very, very significant. And so what you have here is, this is how we create earthquake watches every day. Like I said, that is a part of our daily news. We look at space weather, earth weather, what happened seismically, and also predicting what's going to be happening seismically. The number one factor are these polar magnetic fields, and I'm sort of lumping them in there with the coronal holes because, as I said, I believe these are literally the exact same fields. They're just in the process of flipping. And so the primary earthquake factor is our coronal holes. Second, and a very, very close second, is the geometry of the planets. And as Kong Pop was saying, because we have this resonant connection, we have this interaction with all the spheres in the system, Earth does not even need to be involved. You might remember that. Kong Pop just mentioned that a few minutes ago. The Earth does not need to be involved in these planetary alignments. Because if the sun is involved, if the sun is shaking, we're going to couple with the sun and we're going to shake as well. And of course, third is just general space weather energy as well. Things like the CME shock waves, things like the large solar flares, sunspots, something that's actually proven itself over the past couple of months to be a pretty good factor are those solar sector boundary crossings I mentioned when Earth passes up and down through that heliospheric current sheet. But those are generally considered the third factor we use. But indeed, it is only when we see these things coming together that we tend not to miss big earthquakes, and that we tend not to call out periods of significant earthquake watches and have there be no tremors. So, question at the start of this talk was, does the sun trigger large earthquakes? And if you think about it the way Kong Pop was describing it, you might want to say, well, yes, the sun is triggering earthquakes, but there's a lot of other things involved as well. Just like I might say, yes, the coronal hole is a significant earthquake factor, but there's other things involved as well, like the planets and coronal mass ejections, other things of that nature. Well, the answer is fairly definitive. It's a yes. There will always be people who will push back against stuff like this, against the electric universe as theories as a whole, anything that challenges the mainstream, really. However, we've now got professional statisticians showing us that this stuff is real. If that's not your cup of joe, come over to the Suspicious Observers. Do this day in and day out. And I don't mean watch me do this day in and day out. I mean you do this day in and day out. There are hundreds of people all over the world emailing me their earthquake predictions every week, and they're correct. I promise, if you watch the news every day for 30 straight days, you'll predict your first earthquake. And you'll be right. You will. One last thing I want to mention is the mechanism for how some of these things could be working. And I mentioned that there have been a number of mechanisms proposed, and that I was most in favor of Kong Pop's explanation. The idea is piezoelectric, and I'm sorry if I botched that pronunciation, but essentially this is the buildup of energy beneath the ground and the triggering
of that energy. You know, when a coronal mass ejection sweeps by and hits Earth, it's not like the Earth wobbles. There's an integration of this energy. As Kong Pop said, we have noticed things like changes in the atmosphere in terms of ions before earthquakes. We've noticed quite a bit of that. It's what's coming to be known as lithosphere, atmosphere, ionospheric coupling. A man named Sergei Pulinets has basically dedicated the last decade of his life to studying this and this alone. Essentially, what we have is literally electric coupling mechanisms from the edge of space down to the ground. And what Kong Pop was mentioning earlier, we have seen electron content variations, how much energy is in the atmosphere before the earthquake. We have seen critical frequency variations before these earthquakes, which is the critical frequency is the maximum power wave that you could skip off the ionosphere. We've seen that change as well, and that is wholly a factor of how much energy is there to begin with. We have seen evidence of this energy above and below that layer as well. We have seen evidence of electric currents, static, going through the ground at up to 1,000,000 amperes during these seismic events. And we have seen local and global scale magnetic fluctuations before some of these events. The only real way for this to be possible is if you've got an external trigger. You don't have something beneath the ground. Maybe you have it releasing some positive ions and changing the atmosphere a bit. You don't have it vastly changing the ionosphere. You don't have it perturbing magnetic fields. You don't have it surging electric current through the ground. What we're talking here is something external. And while, you know, you never want to express certainty, absolute certainty, the p-value on the study, the day in and day out, and the logic of just how well this works, combined with our observations of pre-earthquake signals, not really having a good explanation if you're looking internally to the Earth. Combine all these things together, and you have to say that you're pretty confident that the sun does trigger large earthquakes. Thank you guys for listening.
Doesn't mean stronger. Bring the heat. Pack a punch.
Good morning, folks. The sun is waking up a bit here. We've got sunspots, some small solar flares, peripheral activity, and also another day of amazing news articles, so let's get to it. We're starting at spaceweathernews.com. We're looking at a not-so-calm last 24 hours on our star. We see activity incoming at the active region, but also across the Earth-facing disk. Northern filament collapsed this morning, and as the smaller flares kicked in, the plasma filament on the south whipped around the quadrant, and upon its descent, triggered another plasma filament motion through the southern Earth-facing latitudes. It does seem that the release of the filament propelled a short uptick within the region itself, able to crack up to B-class flare range and even briefly into C-class, and which has a fair amount of size to the spots and numerous umbra, but I can say that there is a bit more spread between the lead and trailing umbras than it appeared yesterday, which matters because the magnetism appears to be split that way as well. Let's come to the solar wind, where the slightest of intensifications is underway, but the telemetry is nothing scary. This is more of a shifting profile than a true impact shock wave. Nothing going on geomagnetically as of yet, and little is expected. Tough to say if these coronal holes will have the equatorial IMF reach to affect our planet, at least more than the weak impacts we've seen of late. The only lithospheric note for the last day is an uptick swarm that hit Taiwan, got as high as 6.1 before backing off in the latter half of the day. Suppose we'll also mention North Atlantic refuses to settle down from Iceland to Greenland. Definitely an uptick there. On to the case of the disappearing star. But here, the mystery solved leads to more unanswered questions. They have come to believe that an eclipsing binary is acting on the visibility here, but the problem is that none of the three mainstream binary formation mechanisms allows this particular relationship and particular pattern. Models and math are essential, but the visible observations of the real universe trumps the models. Up next, modified Newtonian dynamics is one of many dark matter alternatives that have been popping up these days given the fact that nobody can find dark matter. This one plays off our recent story about dwarf satellite galaxies in the Milky Way, Andromeda, and Centaurus A. You'll remember the observations here didn't support dark matter models, and so now we have a paper immediately taking notice of the dark matter debunking, and this is the tenacity and urgency we need to see among physicists these days. Up next, the awesome R Aquarius star. Well known for its beauty and its cosmic jet blasting through the structure, this Chandra time-lapse focusing on the X-ray component of the composite wowed us all a few years ago. Now it has received its highest resolution imaging ever. The ways in which we are able to see the fine structure of the cosmic jet are now indescribably telling of its dynamics. Amazing shots in that paper. But there's something else while we're here on this star and its imagery. The primary aesthetically beautiful visible structure is the cosmic jet blasting through what looks like a ring. Not unlike the dust ring recently found around another system of note, one can't help but wonder if there is a similar dust belt around R Aquarius as well, something to keep an eye on. Folks, those upgrades and the increase in the price of the disaster prediction app is at hand. If you are hoping to get it at the cheaper rate, definitely got to do it now. If you missed last night's recap video, we hit a lot of important topics. We greatly appreciate your support. We've got your wind maps and shots of our star to close. We'll do this all again tomorrow right here, but right now it's 4:20 a.m. in the new Valley of the Sun. Eyes open, no fear. Be safe, everyone.